Welcome back, everybody. We're here with Sven van Straalen, who has the most small title I could ever pronounce. So I'm going to let it do you by yourself. Which session are we here for, Sven?
We are here for why should you use Web Workers to improve your UI?
Yeah, it's a long title. I feel it's a bit entangled, like some noodles or something, but yeah, we got it. Yeah, I'm glad we're here. I saw some people making selfies already on the screen. I see even a whole family sitting there all together watching us. That we came a long way from our bedrooms.
Yeah.
Definitely. Yeah. I would say we were just small puppies while we were in our bedrooms, and now look at us, big dogs.
In an actual studio.
Yeah, an actual studio with the testers in the second studio. Know your place, people. Anywho, back to the session. Sven van Straalen is here, a beloved colleague of mine. He worked at Capgemini, I guess, as long as I have, maybe even longer.
7, 8 years?
I guess, because since I've been here, I've known you, so that's a good thing. I'm not even going to pronounce that word, Jurgen. I don't know what it means. I can but back to the session. Yeah, what is the thing with web workers? Why do you want to talk about that today?
It's basically a technology which is not often used, and there are many reasons why. And I want to make them back to differ, basically, to give some use cases around web workers, and probably, from my perspective, for what I see for what's going to happen in the future with the web, I think eventually it will make more sense to use them, and that's, I hope, to prove you all.
Yeah, probably a tsunami of information coming your way. So I will say, take it away. The stage is yours.
Perfect. Thank you. When I started investigating web workers, it was because of a game. Yeah, and it happened on a conference, the JFall, basically, where we saw some Space Invaders, where we had made this game so that people can play Space Invaders on this beefy machine that I have right here. With just a MacBook, everything was working fine, and then eventually we came to that conference, and we had there these other computers, and they had it were HP laptops. They were quite slow, and then when we booted up the Space Invaders, we saw a lot of lag and things skipping, and yeah, it was not working. And then eventually we found out, okay, the paint of the browser is too slow. And why does that happen? And that's what I'm going to talk about. My name is Sven van Straalen. Started in Capgemini in 2013 as a young professional, being a developer, and now I'm doing talks like these. I'm an architect, and the most important parts, I hack weird stuff, like with Arduino's plans, if you have seen a later build talk. With COVID-19, my vegetable garden is one of my favorite hobbies. So now back to web workers. So before we start working with web workers, I want to tell something about multi-threading to get you all up to speed. This is not going to be a talk completely about multi-threading because that will take too long. I'm going to do it in super short what it is. Basically, when we see the single thread, it's most of the time it happens like this. So your computer is going to execute some tasks after task after task. And with multi-threading, not to make it complex, you can basically add an extra thread what's going to do some computing power. So take, for example, here we have this task in purple, and those are quite heavy. We could say if it's only JavaScript or whatsoever, we move them to a second thread. In Java and in C and in Python, these things are quite known, and there you can even have shared variables with them. And here I'm going to tell you how you can achieve something like this in JavaScript. But then we had one problem. JavaScript is single-threaded. So there is actually no possibility to do multi-threading with JavaScript. So this was the end of my talk. Thank you for being here. No, I'm joking. There is for sure a way to make multi-threading work in frontend. And that's basically because the browsers, they introduced something, and that's called web workers. And they basically work for you. So what are web workers? it's basically just a simple thing where you can execute some JavaScript task where you think, okay, I need to put them aside. They will take long, or they have to do a lot of stuff. And then eventually when they're done, then you can get that information back. So what happens when you actually start a web worker? So we have our browser, and then when you initiate a web worker, what actually happens? Basically, a headless browser appears. And that headless browser, so doesn't have a head, so you doesn't have a view or whatsoever. So what happens that you have some JavaScript environment without document and a window, but you can still execute JavaScript, which is nice because that's what we're gonna work with. So to communicate with this web worker, you basically use something of an API which is called post message. Post message is already a long time inside the browser. Actually, web workers are also, but not yet used that much. But I'm going to show you how this is eventually going to work. So there are certain web worker types. You have something which is called the dedicated worker, where I'm going to heavily focus on today, which is basically a single instance of a new thread we're gonna make. You have a shared worker, where you basically can make it's similar as the dedicated worker, but you can use it in multiple tabs. And you have something like the service worker, and this is, I think, already known by a few of you, and that's for progressive web apps, for example, that you can do some proxying and caching of these API calls. I won't talk about this one. I will focus primarily on the dedicated worker. Why should we use these workers? Well, basically, the main thread that we have is also known as the UI thread. So in this main thread that we have, not only our JavaScript executes, also our user events, so keyboard interactions, mouse events, and all these kind of things are coming in there. The JavaScript itself, what we have right now. We have the styling, of course, where he has to take what he has to take along the browser. He has to do some layouting. He has to do the paint, and also some compositing. And basically, every heavy part of the JavaScript that we have, that will break up the events and the style and the layout and the paint. So if you want to maintain your 60 frames per second for your application, you basically want to make sure that the JavaScript is 16 milliseconds. Because if you divide your 60 frames into of your second, then you will have 16.6 milliseconds to work it. And in that 60 milliseconds, you have to make sure that you have some visual representation for the user. And then basically you have this web worker, and then you can basically fake it until you make it, to make sure that you show already something on the screen, that it can be interactive, and then have the web worker doing the heavy load of computing power, and then get it back whenever it's ready. So why are we not using these web workers? Because most of our applications that we create are forums and are not that extreme applications that will need it at this moment, because they heavily focus on UI. We have these UI frameworks that are basically where we attach an input field in Vue to a V model, and ng for Angular, and then it's done. Post message API is quite horrible to use because you have to send events over and over, and I will show you that later. And it's not really fancy if you can work with a super cool framework or whatsoever, because these days I think that's the most important thing for front-end developers to look at. But I see a lot of people here, so I'm super happy that you're all in my talk discussing this. But there are use cases to use web workers. And the use cases are not so known right now because we still need to get there. But as you see in the latest talk, we had something about edge computing, for example, where we get streams of data flowing to our APIs, to our screens, basically in the browser, and that data needed to be parsed, and then put on the screen. And basically, it's every time then blocking the UI, because every time it needs to parse, and it goes so fast that every 10 milliseconds, for example, you have some new data. So you could use that to put that in a web worker, let's say with a WebSocket, or you put your APIs there, not cluttering up your UI thread, and keeping it all safely maintained somewhere else so that your UI can still work as it should be. And for frameworks that we have right now, like Vue.js, React, and Angular, most of the time a Redux pattern or a Flux pattern is being used there to make your application. And also there is a part of your application which basically doesn't need to be on the main thread. And that's, for example, the dispatcher and the store, because there you store some data, and your view, basically there happens the interaction of your user that sends out an event or calls a function or whatsoever, and then from there the computing power actually, the JavaScript computing power actually happens, and you don't need to do that anymore in on the UI thread. I see some really nice selfies being made, by the way, so it's super awesome to see what's happening on those screens. But now let's dive into some code, because that's basically how do the web workers work. So I've set something up. I made them super simple, and I need to make it a bit bigger. I hope it's visible for everyone. Else, let me know. So this is definitely not production-ready code, okay? But this is just to explain how web workers work. So first, here we have the start of our new web worker, and we include the JavaScript file which is needed for this worker. And basically, so what happens here is that we create that headless browser where we can execute JavaScript. Then I created something which is an on-change event. So basically, I've here on the HTML, I created some basic input fields where we are eventually gonna, just calculate two numbers with each other. So this is interaction in our main thread that should happen because that is communicating with the UI. And then we use the post message to send along the values that it needs to know. And then I have also the second one sending these post messages. And we also want to listen to the web worker when he's done with his heavy lifting of his work. So if you then look into the web worker, how does that look like? So here we have our new thread, basically. And there we listen to this new message that comes in, and we get the data. So as you can see here, it's just actually kind of like an event. And then basically what we do is, okay, we calculate the result, which is just a sum. And then eventually we check first if it's a number. Is it not a number? Then, okay, I'm sending back a message like, please write two numbers. If it is, then we just add it to each other and send it back. So let's see how that works. So I created a nice page. So here we have our simple sum worker. So if I put one number in, oh, it immediately already reacted, where you can see, let me make this bigger as well. So I posted something to the worker and eventually send it back, and then we put this result on the UI. This is super simple, but then you don't see the result that it actually gives of the web worker where it's actually best in. So I will show you another example where I'm going to show you what the web worker can do to make it more performant. So we're gonna compare one side with the web worker, and we're gonna pair one side without the web worker. So I have here two versions. I have the non-worker variant, and I have a worker variant. So let's start with the non-worker variant. Basically, what I'm going to do is I'm going to calculate the prime number of 2 million. So here in the code, it's quite simple for the non-worker. We have here some nice lorem ipsum text, and I show you why we need that in a minute. And then eventually, when they click the button, this while loop starts, where we're basically gonna say, okay, do this while loop so many times, and then give me the result. And basically, every time in this while loop, it tries to update the UI. So when I start this, it will block my browser, and I'll show you why. So now I'm able to select and have interaction with my screen. If I click this button, this will be over. So I hope my computer stays alive. We'll see what happens. Here we go. So now I'm trying to select again. Here we go. It's done. And now I see it was blocking for a few seconds there. So if I open the debugger tools, we can actually measure this. We have something which is called the performance tab over here. And we can actually measure what actually happens whenever we execute this heavy lifting function without having this without having this worker. So I will click here, and then basically it starts profiling, and I will click the start again and try to select my text. Here we go. We're done. And let's see what happens. As you can see, we have here a very big red bar. And this red bar actually means you have yank on your application. It basically means it skipped some frames to make everything work. As you can see, it says even, it's a long task and whatsoever. And basically, we're not doing any interaction with our front end. So why not put this computing power inside a worker? And that's what I'm going to do right now. So here we have the different program with a worker. So I'll show you the code, what we do. So in the index HTML, we have again the event listener, and then we say post message, please execute our worker. And whenever he receives a message, we say, okay, update the screen. And this is how the worker looks like. Well, basically, whenever it receives the message, we do start. And then with the start, basically, this function executes. And then every time it finds a prime number, it will update our screen, because here it posts messages back to the UI saying, hey, I found a new prime. So what will happen? I'll click on start again. And, oh wait, let me increase the screen of the font. Here we go. And as you can see, it still was interactive, and you saw actually these numbers being executed. And think of now this being an event stream of whatsoever, with every time new data coming in. Let's think of IoT, for example, where we are measuring plants. Basically, you want to know, or whatever your use case in these kind of reactions will be. And if we also open up here the debugging tools again, and then if we measure here the performance, let me refresh the page. A nice cool thing happens. So it's still working, and we're profiling. Here we go. This always takes a while, because now what actually happens is that we did so many microtransactions. So all the tasks, he's now listing them all out. Because every time we execute a new function, and we did it for almost 2 million times. Well, less, but so much that he starts still computing. Here we go. There it's there. And we see still a small red bar, but it's already way less. And here you can see that we eventually have this web worker executed. So if we have the main thread, if I close that, then here we have this worker. And in this worker, he has done the task without blocking the main thread. And in the main thread, we basically have all these small micro functions where they are basically every time updating the screen. And you saw that really visible being on the page. So this is the basics of how these web workers work and how they can help you in improving your UI. Just one more thing. Eventually, we have these complex workers, because now we did just the one event. But if we are going to look in how we are going to do this in our real world applications, let's take, for example, for a bank, we will have one shared worker where we manage the session, where we manage maybe API calls, where we have a lot of UI components, or we have image recognition, you name it. It can all be there. And then we have to work with this post message, and we have to keep track of who has been calling this web worker actually, and where do we send this back to, and we have maybe then a switch case with all kind of execution models going around, and that's not making any sense because that will be such a big script figuring out, okay, who did what and how do I send this data back. And therefore we have something, and that is called comlink. Comlink, that's just a small framework which basically is wrapping your worker. And this worker of actually comlink itself, you can easily create just a class, like over here. And then you have your methods, and comlink will do the rest for you. So you can just execute your method just like a normal way of working you have done already in your JavaScript, which makes it so much easier to integrate web workers. So you don't need to use the post message anymore. Actually, behind the scenes, comlink is using post message, but the maintenance of the IDs and which functions you have to figuring it out basically is all done by comlink. So you can basically just call the functions again, which makes it quite easy to use. I don't know how much time I still have. Okay, then I'm not gonna demo that so that people can have some questions. And if the question becomes, 10 minutes, okay, then I can show it still. So also I have a nice small script stolen from GitHub, from the comlink GitHub, basically explaining how comlink then works compared to this post message. So here I created this super awesome basic worker of a page again, basically, which has just the title saying comlink copy paste from GitHub, where we introduce our worker again, only a slightly different way. So we load in our worker, and this you should not do for production code, of course, but it was just for the sake of it to have it quickly, easy working, but probably use something like Webpack or whatsoever to make it in a proper way. But this is just for showing how comlink actually works. So what we do basically, we have our worker, and then we wrap it into comlink, basically creating this wrapper around the worker. And then eventually what we do here, basically we say, okay, hey, we have one variable inside my worker, and I want to read this. And every time it's updating, I want to be notified about it. And in my web worker, I also have something which is a nice method where we do some computing power. So how does our worker look like then? In this case, we also import here comlink. And then we create our object where we have our information. And there we say, okay, I have a shared variable basically, which is the counter. And then whenever I execute my method increment, then it will basically bump up my counter by 1. And then I expose it through this method, this object. What now basically happened is that this value that we have over here became a shared value. So we are not worrying about post message and about events. We just have something which is basically just a value. So as you can see in here, we're just reading out a normal variable as what you do for your old objects. So we don't have to worry anymore for, okay, how it works in this worker. And then you can also execute just normally how your functions work. And I will show that now also how that's actually going to look like. Oh, yeah, okay, it already started. So basically what happened, right? So in the first place, over here, it alerted me with my first value, which was basically 0. And now I'm gonna click on the button, and then it's gonna act, because now it's here, it's blocked by the JavaScript, by the UI, because alert always blocks the JavaScript. And then when I click OK, it will execute our next line, which is basically the await, where I'm gonna execute the function of the worker, which is increment. And then when I click that, then it will show again the variable, and then it will be a 1 if I did everything correctly. And here we are. And then we had communication just by a variable and executing a normal JavaScript function, and then still be using web workers. And then it becomes quite easy to introduce web workers inside your normal application. I hoped you enjoyed my talk. I did very enjoyed it to present it here. I have a lot of links where you can use, and thank you. This was it.
It's definitely a lot of links. You didn't exaggerate that. So maybe those links be shared later for the people who want to access that?
Yeah, I think I can also share the presentation. Don't know how we're gonna do that, but that's probably we can figure this out to share it. I'll put it on my LinkedIn.
A special shout out to Jan and Nieland backstage answering your questions, and now probably fixing the problem of these links.
Yeah.
Yeah, thank you for this presentation. Cyclomatic complexity at its finest. Thank you for explaining. That was still a word I had to do. But I see some questions from the audience coming in. That's something we would like to ask you.
Yeah.
So how secure is a web worker?
Oh, that's a very good question. And I was going to mention that, but I basically forgot. So thank you for this question. They are quite secure to be used in the browser. Post message is known for its tricks that it could be hacked by a different tab or whatsoever. But what you see with using it in a web worker, because you have your instance already known in your JavaScript, it's quite hard to hack. And if they already have been hacking around in that browser, then they probably have access to the RAM memory anyway, and then they could have the information just from there instead of using your web worker.
Sounds like if you were screwed already, this doesn't make any difference.
This doesn't make any difference.
Cool. Another question from the audience. How can we put async code in web workers?
Asynchronous code in web workers is quite possible. So you can not use document or the window, but there is some kind of context there that you could use fetch or whatsoever. So you can do API calls coming from a web worker. And if you actually have the API call in your web worker, you can even have the service worker proxying it, and they will communicate properly. There is quite a lot where you can make it asynchronous, but most of the time you see JavaScript blocking functions being in the web worker, and the asynchronous can be there. Most of the time you will show a spinner anyway on that moment.
Clear. And then a final question, and I think that sort of wraps around. I don't know if it's the final question, at least this one. Wrapping around back to the subject, you told us we should use web workers, right?
Yeah.
So say we have a site, a project, whatever we're running. How to determine which code we put into those web workers?
How do we put, yeah. So one way to figure this out is basically using this performance tool. So I hope this is gonna work out nicely. So let's go to this nice Capgemini website, and then let's run it over here. Let's see if we are going to need web workers. So here we can probably see eventually some random blocking. Oh, it was actually quite fast. Ah, yes, here we go. So you see these red bars? That's where you know, okay, there's something wrong there. and you could probably improve some code in there. Sometimes it's not even then you need to use web workers, but it definitely can help then to look into that. What also, if you want to determine it, is most of the time it's quite a complex situation to calculate your execution of your program, and then you have but look for how to determine parallelism inside your code. That will basically tell you, there you find a lot of information in how to find the weakest link inside your code, which is taking much effort, basically.
For some reason, you sounded surprised that the Capgemini website was quite fast.
Yes.
It's the company we work for. We should promote it a little bit, maybe.
Yeah.
No, I know where this is going. I see one final question then from Ruben. With the comlink example, you had the main thread update the UI after the web worker incremented the value.
Yes.
I don't see a question mark. That makes it quite difficult for me, but yeah.
But I think it's more a notification. So alert is not really updating the UI. So if we would say, let's take, because alert, it will just pop up. It basically what happened here is that instead of, I was not updating the HTML in this case. Normally you would have here then a document selector and then add something to the screen to make it actually update the UI. But this is more an example that you will see for code like Vue.js or React or Angular, that you have this object attached to this comlink variable, and then from there it automatically updates and all these kind of things. But I did not really have the time to make that happen at this moment. But if you want, I can show you some nice examples in the real world.
Cool. Time-wise, I see another question. I think we should be able to fit that one in. Is the usual way of doing... Sorry?
No, go ahead. Sorry.
No, now it's time for you to...
Yeah, no, I was reading it. And,
So you know the question already, but for the visitors at home, the viewers, I should say. Is this the usual way of doing things, or should the worker update your UI? My bad, pressed enter before I was finished with... I guess same question, but yeah.
Yeah, the worker is not able to update the UI. You can't use document query selectors in here. So, because it's a headless browser. So if I go to, so with comlink, it's the same. So maybe I can actually see if we, because it's a worker, right? So if I put here document.query selector, I had an H1, right?
Well, you're gonna find out the hard way.
Yes.
Live demos, people, always a good idea.
Here we go. So this should break because document doesn't exist in the worker because we have a headless browser. Oh, that was not the intention. So saved it. Let's get to the console. Here you go. Because in the worker, it's not there. So it has to communicate through post message basically to make this happen. The only thing is what comlink does, it exposes the methods that you have to your UI, and then you basically have your single thread just calling execute some functions, and read out the variables that are in the worker, and then comlink basically makes these communication between these events. I hope that makes sense.
I saw some people nodding, so that's a good sign, I guess.
Yeah.
Yeah, I think it's time to wrap things up. I see one thank you from Reynaldo. He said he was actually able to follow it. I don't know if that's an accomplishment. I don't know how good he is at this stuff. But yeah, I forgot one word when we started this. Like bubble tea, if there's only one thanks, a bubble tea with one bubble, of course, isn't nice. So I'd like to ask everybody to thank Sven for this great presentation. Put those hands together because we can see you guys. And yeah, you probably can reach Sven via other channels if you really want to talk to him.
For sure. For sure.
I see a thumbs up. That's also a good sign.
Nice. Thank you very much.
Any special shout outs you
I
want to
see
do?
some hands up going on. Yeah, nice. No special shout outs. I have no idea. Hi, Mom. That I see.
Cool. Then I think it's time to wrap things up. We'll have a networking carousel coming up in a bit. So yeah, keep your cam on and keep here. And after Sven left I don't want to say the studio because you're still welcome here, of course, but at least the stage, we will have Hidde de Vries later on, who's going to talk about components and accessibility. So I'd welcome everybody to be there. And for now, thanks for watching Sven do his thing.